Hello. Is the stream working? I'm not sure. Hello. Hello. Okay, I think the audio is working fine. Um, so in this video, I will be solving it live, so you will be able to hear my thoughts, what I think while solving the problems. Right now, I'm not sure how many problems I will solve, but let's see if the contest goes well. I will make this stream public. Okay. So right now it will be private, and after the contest, it will be public. I will use this whiteboard for the rough work and Sublime text for coding, and I think I will use m2.codeforces while solving the problems. So we still have some time remaining, 1 minute 45. So we still have 2 minutes remaining, and the length of this contest is 2 hours 15 minutes. Okay, I think there is some issues with the light. I just got a power cut, so I think it will get fixed on its own. Let's see how it goes. Yeah. Okay, we have 1 minute remaining. Is the stream still working? I think it is. I think I will just shut the video down for some time. Can I? Okay, we have 30 seconds remaining, and 320. Okay, so first problem, Rudolf and the ticket. Rudolf is going to visit Bernard, and he decides to take the metro to get him. The ticket can be purchased at a machine that accepts exactly 2 coins, the sum of which does not exceed K. Rudolf has 2 pocket coins, and in his left there are n coins of denomination this, and in the right there are m coins with denomination is this. Okay, he wants to choose exactly 1 coin from the left and exactly one from the right pocket. Write the 2 pockets in totals. Help Rudolf determine how many ways there are to select indices f and s such that f will okay like that. Okay, I think I get it. So what do we have to do in this case? So let's first take the input. So we have I think I can do it kind of in brute force manner also, because there are only 100 cases. So 100 into 100 is also 100 into 100 is like uh, 10 to the power 4. So I think we just need to do a brute force in this question. So we have first we have in the first test case we have three numbers. Is the recording still on? Yeah. So first we have NMK. Okay, int n, m, and k, cn, n, m, and k. Then we have the number of coins in the left, right, and the maximum sum of the two ones. Okay. In the second line, we have n integers, b of n. So let's say vector b of n numbers, and let's say c of m numbers, c in b of I. Then for I in range m, c in c of I. Okay. Yeah. Now this is also till 1000 only, and now one thing I can do to optimize this is that I can sort these two values, but that is also not needed actually. Let's say int count, or let's say int answer equals to 0, and let's just do it brute force, like in a brute force. So let's say int j in range m if a of I plus b of j is less than equals to k. I will say answer plus plus, and in the end I can say this should be b and c, and then I can simply say c out answer, and then let's just copy the input and see the output. So we have 60412 60, yeah, that is correct. Let's just submit this code. So we have a problem, language is C++, 14 and 17. Okay. I think it will take some time. Let's move on to the next problem. That is Rudolf and 121. Is the stream still working? Yeah, I think it is still working. Okay, Rudolf has an array A of n integers, and the elements are numbered from 1 to n. Okay. Uh, in one operation, he can choose an index I and assign a I minus 1. Okay, so we can decrease the. Okay, we have to do all these operations. A I minus 1 is equals to. So we are decreasing by 1 the left index. We are decreasing by 2 the right index, and we are decreasing by 1 the. Okay. Rudolph can apply an index I can be used 0 or more times. Okay. Can he make all the elements using this operation? Okay, this will be, I think, tricky. Let's see. First, we have 13552. Just a second. So we have 13552. So if we have 13555 and 2, what can you do? Like if I want to make this 0, okay, so I will simply say like, okay, let's make this 0. This will be decreased by 2, so this will become 1, and this will be decreased by 1, so it will become 4, and then we have 5 and 2. Okay, then to make this equals to 0, I will say like, okay, so this becomes 0, this becomes decreases by 2, and then this decreases by 1 also, 4 and then 2. So now I think like, okay, this number is 2 times in the end that whatever we have. Yeah, I think this is simple search, like 111 can't be made 0 because this is not 2, right? So it will return false. Then yeah, I think like that. This is also just a brute force. What are the test cases? They are 2 into 10 to the power 5. Yeah, we can solve it in n log n time like that. Okay, let's just copy the input, and now I'll paste the output. So we have, first we have an integer n, scene n vector int a of n. For I range, I will have to start from 1 and I will have to go till I minus 1, right? If a of I is greater than uh, a of I minus 1, right? And also, and first of all, it should be greater than, like, if I have a number x, x and x, then this decreases by 2 times, right? And these all decreases by 1. So since I want to make this equals to 0, okay, I will have to, like, this will decrease by 1 x times, so this will should decrease by 2x times, right? Yeah. So what I will do is, okay, is greater than equal to 2x, and then a of I is less than equals to 2 times a of I plus 1, right? If this is the case, otherwise I will, there is no possible way to make it like that, so I will simply say no and return, right? Now I will do, like, okay, a of I minus equals to a of I times sorry, a of I minus 1 times 2, right? A of I plus 1 minus equals to a of I minus 1 times 2, and if in the end a of n minus 1 equals 0, then I will say C out yes, otherwise else I will see out no. I think that this is the solution for this problem. So we have yes, 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 which is completely wrong. Why? Okay, let's try to debug this. Let's only do it for the first test case. Okay, let's do it for this test case. So the answer should be no, but we are getting a yes. Why is that? Debug A. Okay. Oh, I forgot to take the input. Okay, for I. Okay, now we are getting a no, that is correct. Let me just copy everything again. Okay, we have yes, no, and in the third test case it is failing. So we have 1, 2. For this test case it is failing, right? So I will simply, like, okay, I will say okay. I think it is because the a of I minus 1 was already 0. So I will say, like, if a of I minus 1 equals 0, then I will simply continue. Yeah. Okay, we are still getting a no. Why is that? Okay, for the third index 0, 1, 2, 3. Okay. Wait a second. So first my array becomes, like, first my array was this, then it becomes equals to, then we go to this index. Why does it become this? Hmm. I'm starting from I equals to 2 because I skipped this index. Okay, now we are at 3, and I have to say like, okay, I have to first decrease this by 1. So a of I should be greater than equal to a of I should be greater than equals to this, otherwise I won't be able to do it. Yeah. So I was at 0 1 2, then I should have what is happening, like a of I minus equals to this value, and I have to decrease this by 1 only. Yeah. Okay. I also have to decrease my a of I minus equals to sorry, a of I minus 1 equals to 0 in the end of it. Yeah. So a of I minus 1 turns to 0. A of I will decrease by 2 times of this value, and this one will decrease by this much amount, right? I think. What is happening? Zero, 1, 2, 3 for this third index. Like, okay. Now I'm not sure what is happening. Okay, first we have an integer 5, then we get an array of these numbers. Let me just write it down and check. Is the stream still working? Yeah, it is still working. Okay, so first we have 0 1 3 3 1. So we have 0 1 3 3 and 1. And now we have this. So I will decrease this by 1, decrease this by 1, decrease this by 2. So this becomes 0 0 1 2 1. Yeah, so in the end these will become 0. So this should be correct. What am I doing wrong? If a of I minus 1 equals to 0, then obviously I don't need to do anything. Okay. Oh, so in the end, in I equals to 2, I equals to 1, I ended up with this case, like in the else case. So my a of I should be greater than or equals to 2 times a of I minus 1, that is correct. And in the second test case, my a of I plus 1 should be greater than or equals to a of I minus 1. That is the correct test case, right? Yeah, I think now it is correct. So both of them should be 0, and now we are getting yes, that is correct. Okay, let's just copy this again and paste, submit. So getting yes, no, yes, 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 no. Yeah, that is correct. Okay, let's remove the debug lines. Okay, let's submit this whole code. Yeah, B problem, and this is the C++ 17. Yeah, submit. Uh, did I not submit it? I think the Codeforces is slow today. Is it just me or is it happening with everyone? Okay, let's move on to the next problem, I think. Uh, or should I just wait for the verdict? Even I am not sure. Okay, let's just wait for the verdict. Mm, yeah, it got accepted. Let's move on to the next problem. We have Rudolf and the ugly string. Okay, Rudolf has a string S of length n, and Rudolf considers the string S ugly if it contains the substrings PIE or the substrings MAP. Otherwise, a string is, for example, this are ugly strings while this are beautiful strings. Okay, substring. Substring PIE or the substring MAP, otherwise the string will be considered beautiful. For example, this are ugly, and okay. Rudolph wants to shorten the string by removing some characters to make it beautiful. The main character doesn't like to strain, so he asks you to make the string beautiful by removing the minimum number of characters. He can remove any string character from any position in the string, not just from the beginning or the end of the string. The string A is a substring of B. Okay, okay. So you have n till n goes till 10 to the power 6, and the length of the string is okay. So you have to do this in big O of n, strictly big O of n time. And generally, when we have a problem of strings, it is generally done using stacks, like such kind of problems. So let's see. The two strings are PIE and MAP. Okay. So if we have, okay, let's just clear the page. Let's say we have PIE and MAP. So can it happen like if I delete a map, can it become a pi? I think if I just analyze the uh, test cases, let's say MAP, MMAPN. Okay, let me zoom in. We have MMAPN, APN, APIE, APIE. Okay. So if we see like, okay, we have a map here and then we have a pi here. Okay. So what we can do is, I think it is safe to remove P. Just remove the P's and we are good. Like MMAN, okay, AIE. Yeah, we can remove these two characters and we are good. This doesn't even have that substring. This has, like, let's say MAPPPPIE. Okay, now we are in trouble because if I remove P, then we still have pi. Yeah. So the optimal way, either I have to remove all the P's here, or I can simply remove the A and okay. Yeah, I think this will cause problems when we have a lot of P's consecutive. So what if we have only two P's like MAPPIE? If I have something like this, then I can simply remove these two P's. Otherwise, MAPPP, if I have something like this, a lot of P's, then I should take the minimum of the number of P's, comma 2, because I can always delete this A and I, right? So I think the answers for this should be 2, yeah. And what if we have something MAP, then I can simply remove all the P's, 1, 2, 3, 4, 5, 6 is the answer 6 here. In general, like whenever you have something like this, okay, okay, now when the count of P's is the consecutive P's is too large. So I should say like, okay, let's just keep a count of consecutive P's. Whenever I encounter, I want to count the consecutive P's. And whenever we have consecutive number of P's, then I will say like, okay, let's just do it. Now, I also need to encounter for E's. Okay. In this case, it is optimal to remove these two I instead. Yeah. Instead of removing the P, I should remove the I, right? Hmm. Okay, this is tricky. Definitely not an easy problem. The C problem is solved by how many? Let me just check. Okay, 2000 people. This okay. String A, string B. A string A is a substring of string B, and then you can remove any character from any position in the string, not just from the beginning or end of the string. Okay. Yeah, that is good. So I think the question should be like for every index I have to decide like should I remove this character or not. Like if I remove it, does the pi still remains? But if I do it with dp, then the constraints will be too high. Like let's say we have map and let's say pi, then it is simply like okay, we can remove these two. But what if we have something like a p, then it is optimal to remove one a instead, and then we are good to go. Yeah. Okay, basically we only have one occurrence, so for every map I can remove one p, but for every mapie I can remove simply one character. Yeah, first I have to remove all the mappies. Once I am done with mappy, then I can move to removing the map. So for this I will then like okay, first I will remove all the mappy. Wherever I encounter mappy, then I can simply cut it. Why? I can either why? Because I can simply remove the p and it will become maie. Now we don't have anything. Okay. Then I have to encounter for this case like mapp and map and pi. So I think the answer is simply the count of map and pi like that. Yeah. So what we can do is first let's count the number of mappy in this string. I think I will do this in Python because or should I do this? Should I do this in Python? Uh, I think it will make it easier if I do it in Python. So let's do it in Python. So first we have an integer, then we have a string. Okay. Now I have to search for mappy in the string, and let's also consider a visited array. So let's say false. I mean, should I use rolling hashes? I think it is an overkill to find all the occurrences of that like that. But I mean, I don't need rolling hashes. Can I use a stack? Like let's say L is equals to this. For I in range 5, I mean, I just need to, I mean, it doesn't actually take too much time to just search for mappy, right? So what I can do is, okay, for I in range this n minus 5, I want to remove the substring. Like I should use I should convert this to a list first, and after that, like whenever I find like MAPIE, so I have to bifurcate this into substrings. So I will say like okay, uh, MAPIE. So the substring will become equals to S of from I to I plus 5. And let's do it for single disk case and let's try to print the sub values. What am I getting? We are getting MMA So yeah, MAPIE. Yeah, in the end we only have this, so I should go till n minus 5 only. So yeah, three values, so we have 1, 2, MAPIE, 2, 3, 4, 5. Yeah. Okay, let's actually go till n minus 4. So we have one more. And if this sub equals to this value, let's say, let me just copy it from here. MAPIE. I mean, like, okay, okay. I think I get it now. Let's first count the number of map in this. Let's count of let's first count the number of maps in this, and let's also count the number of pi in this. And from this, I want to subtract the count of mappy. So this is a problem of inclusion and exclusion principle. Okay. So let's say count of map is equals to s dot count map, and similarly I will have two more. So count of pi is equals to this, and count of map pi is equals to map pi. Okay, so I will print count of map plus count of pi minus count of map pi. Yeah, so we are getting 0. Why? Okay, because I converted it to a list. Yeah, so here 2060. What was the expected output? This is the expected output. Okay, we have 202,602,202. Yeah, I think this is correct. Let's try to submit this. And the language is C problem and Python 3. Hmm. Okay, let's move on to the. Should we move on to the D problem now? Or should I wait for the verdict? Okay, let's read the D problem. Rudolf and Werner decided to play a game with friends, and people stand in a circle and start throwing a ball to each other. The number, okay. Let's call okay. The transition can be made clockwise or counterclockwise. Let's call the counter distance from player y1 to player y2 the number of transitions clockwise to move from player y1 to y2. Okay. For example, n equals to 7, then the clockwise distance of 2 to 5 is 3, and the counterclockwise is 4. Okay. Yeah. Initially, the ball is with player X, and the players are numbered clockwise. The person with the ball throws it at distance r1 clockwise. For example, if there are 7 players and the second player after receiving the ball throws at distance 5, either the seventh player or the fourth player. Yeah. The game was interrupted after M throws due to unexpected rain, and when the rain stopped, the guys gathered again to continue. However, no one could remember who had the ball. As it turns out, Bernard remembered that the distances from each of the throw and some for the for some of the throws. Yeah, asked to help him calculate the number of players who could have the ball after M throws. Okay. Now first let's check the verdict. Yeah, we got an okay verdict. Now, okay, this seems like an interesting problem. Okay. Uh, let's see. Okay, let's first take the input. I think I will do this in C++ now. So first we have an input single integer, yeah. Then we have the first line of each test case contains three integers n, m, x. So int n, m, and x. After that, the number of players. Oh, so the light is back. I think I will just turn on the camera now. So where is the video capture? Okay, let's add some filters. Okay. So what do we have now? First we have an input, then we just want to calculate the number of person who could have the ball. Okay. Is this an interactive problem? Why do we have question marks? First line, the first line of each test case contains three integers n, m, x. Now n is till 1000, m is also till 1000, and there are n players. Okay. And the first and the number of player who threw the ball first. Okay. The next M line contains information about each throw in order. Each of them contains an integer r, the distance at which the ith person throw was made, and the symbol ci equals to this. And ci equals to 0, then okay. Burner does not remember the direction in which. Okay, so it is like that. I think this is clear. Dynamic programming problem. Yeah, I think it is a DB problem now. So is this a simple implementation based problem or what? I'm not sure. Okay, let's see. Can I do this using a linked list? No, why do I need a linked list for this? Or is this some kind of ordered set? So let's say we have, uh, what do we have? First we have three throws. Okay, there are three throws. Then we have, the second player has the ball. So we have 1, 2, 3, 4, 5, and 6. Okay. So the first person who has the ball is this one. This one. Then what could happen? Like, okay, I can maintain a queue. Like initially, the second person has the ball. Okay. Then in the then what happened was, okay, he threw a ball at distance 2. Okay. So either this 6 could have the ball. So now my queue becomes like 6, or 4 could have the ball. Okay. So these two are ticked now. Now, and this is removed. So I will say like, okay, let's remove this. Now, after this, they again threw the ball at distance 2. So it could happen like, okay, so I go to 2 again, or I could go to 4. So my new queue can become like 2 or 4. Okay. And from 4, I can go to 2 or 6. So these three are in the current queue. Okay. So clearly, if I try to implement it like this, it will become exponential time complexity if there are too many question marks. Um, and I have to try and optimize it somehow. I think this is some kind of graph or a linked list. Is there some kind of cycle detection? Like, okay, I want to count something. Uh, okay, from here I can go to I will go to this or this. Should I just implement this? This is like taking. There are only two ways, like two possibilities. And when I have a count, when I will say like, okay, let's do it in counterclockwise, then these things really don't matter. Okay, like if I'm at 2 and I throw it at a distance of 2, actually let's make it zero based indexing. So for that, what I will do is like, okay, let's make it zero based. I will have something like 0, 1, 2, 3, 4, 5. Okay, and I will be currently at this index. Okay. Initially we have -1 plus 6 which is 5, so I can either go to this or I can go to this. I mean, this is tough. Yeah, clearly it is tough. Okay, I think I remember something. Like if I'm at some index and it can either I can either multiply the answer by 2, like like if the c was equals to 0, then it is like, okay, let's increase it by c becomes equals to 2, right? And after this point, like if I know exactly, then c does not change, like it goes like that. If it is like clockwise, then the c does not change. But whenever I have a question mark, then only the c is changing, right? Yeah. So what is happening is when we have a question mark, let's say we have some players like 1, 2, 3, 4, 5, 6, and we throw it at a distance of r with a question mark, we don't know. So let's say we throw it at some distance r from here, this will increase the answer. Like if I have 1, 2, 1, 2, 3, 4, 5, 6, so if n is even and if r is equals to n by 2, then the answer will not increase, then no increase, right? Because from here it will only point to the same person, like that. But if it is anything else, then the answer will simply then my answer will increase, or I can say then the answer will simply increase by 1, right? Because I will have for this position I will have two new positions. Now, is there anything else that I have to see? Okay, let's say we have something like 1, 2, 3, 4, 5, 6, and I'm here. Um, okay, what if we have something like odd? Then no, if n is no or odd, then we can't have that. Okay. Now, let's say we are at two positions, this one and this one, and it might happen that these two are pointing to the same thing, right? Yeah. And then this is a problem. What are the constraints? Can I do it in? I think I will just try to do this. I think this is an implementation problem. And if I can just implement this efficiently, then I should be able to solve it. Yeah. I mean, that's just what I think. Let's see. The 1400 submission, I think it is just an implementation based problem. Okay. So what do we have? We have something like this, and I will use a queue. q dot push x minus 1 because I'm using zero based indexing. Now for I am range m, or I can say like while m minus minus, now I have three cases. If my c equals to a question mark, then I will do something, else if my c equals to something like what was it? If we have a 1 or 2, right? 0 means clockwise. Okay, so 0 means clockwise, and the else case, I mean, do I even have to shift them? Like, I know that they will go clockwise, so I don't even need to do anything if it is, I mean, my answer just simply won't change, right? So I don't even need to do in this case, these two cases. Yeah, okay. So if I have like this, then only I will change my answers. Now, what I will do is like if I have a question mark, then for every index I will have something new, right? Let's say a new queue and new queue, okay? For while my queue is not empty, while not queue not empty, okay? I will have to pop these elements from this queue, uh, and then no, this is wrong. This is wrong. Seriously wrong. Because I want to avoid duplicates. That is what I wanted. I can't simply traverse in the whole like that. No, maybe I can because N and M are only till 1000. Yeah, I can actually traverse them. So let's say vector int visited of n plus 1 comma 0. Initially they are not inside the queue. Okay. For i in range 0 to why is this not working? Okay. For I in range 0 to n, we have n if visited of I, if it was visited, then I will say let's add it to the queue. I will say visited of I equals to 0, visited of uh, I plus n mod n equals to 1, okay, visited of I minus n mod n plus n mod n equals to 1. So I now have something like this. In the end, I just need to calculate the number. I think I don't think it is needed, but let's just make sure that it doesn't happen. So let's also go clockwise. So if this is the case, then let's also go clockwise. So I will say like this. And in the else case, if it is 1, then I will remove this statement. Like if my I was 0, and then I'm going one step, uh, I think that, it is wrong. It should be D. So it should be I minus D, right? So if my D is 1, then minus 1 mod n might be equal to minus 1. So it will become plus n, which is 6, 5 more. Yeah, I think this is correct. Yeah. And now I just need to count the number of ones in this visited array. Yeah. Uh, for that, what I can do is like, okay, where is this ending? Yeah. And answer equals to 0 for I in range n. If, or let's say answer plus equals to a of I equals 1, or I can say visited of I, and then see out answer and then. Okay, we are getting a lot of zeros. Do I have to print the indices? Okay. Output the number of players k who could have the ball, and in the next line, output the k numbers. Yeah, so we also have to print the number of indices. Um, but there is something going on. Okay, let's say visited of x minus 1 equals to 1. Yeah. So you have 2, 1. It should have been 3, not 2. So the first is only wrong. Let's try to debug it. Ah, okay, so first we have the ball is with 2. Then then it says okay, let's go in both direction. So from 2 I went in both direction. So no, I did not go in both direction. Okay. So when I had the ball with this person, oh, I think I get it now. What was wrong? Like this is changing dynamically, right? So let's also have a q of int q, and then I will simply push these elements inside the queue. So I will say like okay, visited of I equals to 0, and let's not set these values right now. Okay. After this, I will traverse in this, or let's make it a vector int only. So let's have a vector int and q dot push back of I. After that, I will say like for int I in q. Then I will do these two operations. So now everything will change. And in here I will say like if I'm going only clockwise, then I should remove this, and if I'm going only anti-clockwise, then I should remove this. So I have three indices. These are 2, 3, and like that. Okay. So I will say like okay. We have 246, which is correct. Let's remove the debug lines. Okay. There are some more. And now let's copy this whole thing again. Okay, now let's try to submit this. I think I will do it on m2.codeforces only. So submit. This is the D problem and the language is C++. Submit. Hmm. Should I move on to the next problem or should I just wait for the verdict? I think I will just wait for the verdict. Okay, our solution got accepted. Let's move on to the E problem. So we have Rudolf and K bridges. I think I will do it on this page only. Okay, Bernard loves visiting Rudolph, but but he's always running late. The problem is that Bernard had to cross the river on a ferry and decides to help his friend and solve this problem. The river is a grid of n. Sorry about the noise. The river is a grid. The river is a grid of n rows and n columns. The intersection of the ith row and the jth column contains the numbers aij, the depth of the corresponding cell. All cells in the first and the last column correspond to the river banks, so the depth of them is 0. Okay. Okay, I think I get it. So these represent the depths. Now, the Rudolph can choose and he could build a bridge over it. In each cell of he can install the support bridge. The cost of installing the support bridge is aij plus 1. Okay. The support A must be installed on the cell IM. Okay. So uh, we want to have a support bridges on support on these three and this is so the minimum cost for this would be 6 and the distance between any adjacent pair must be no more than D. Okay. So uh, iji and iji is j2. So if you have 1 and the distance between these three will be 1 minus 3 which is 3 minus 1 is 2 minus 1 is 1. Okay, so we have so basically the number of blocks that I can skip should not be more than D. Building just one bridge is boring, therefore Rudolph decides to build K bridges on consecutive rows of the river. That is, choose some I, independently build a bridge on each of the rows. Help Rudolph minimize the total cost of installing the support. Okay. Huh. So I think this is a very simple dynamic programming problem. There should be more submissions on this problem. Yeah. Oh, there are only 500. Why is that? What is actually stopping people from solving this problem? Okay, let's try it for this test case. Let's say for some simpler test case, if you have like 0330, then what is the input format? We have nmkd, so let's take it. We have int n, m, k, and d. C in n, m, k, d. Okay. Now, uh, now I want to have the number of rows, columns, and then the ith. Okay, so I want to make a vector int, then let's say my river. So I have a river of length n and vector int length m. Initially, let's say everything is 0. So my river is a 2 cross 2 matrix, right? So something like that. Okay, and distance can be 1 actually. Okay, so I can skip like this. I mean, I can easily do this in using dynamic programming. So I can say like big of n into m square. So that's the support no, m square time. Hmm. Okay, let's try it for every test case. So nmkd, what is k? Okay, he wants to build the k bridges on consecutive rows of the river. Okay, so all the rows should be consecutive. So basically, I want to find the total cost for building this, and this for every row, and then I want to minimize the total cost of building it. So I want to find the minimum total cost of the consecutive. So I think that is also a sliding window problem. So they have combined them together. Okay. Okay, let's try to find it for this test case. We have 0, 3, 3, 0. So we have 0, 3, 3, 0. Then we have 0, 2, 1, 0. 0, 2, 1, 0. Then we have 0, 1, 2, 0. 0, 1, 2, 0. And then we have 0, 3, 3, 0. Okay. 0, 3, 3, 0. Now, uh, if we have this, like, what will it cost? Like, my maximum distance is 1, right? So I have to build a bridge here. Now, if I want, I can take this, and I mean, like, it will take me a cost of 1, then plus 4, then I can skip it and make a bridge of 1. So it will take me a cost of 5 units to make a bridge on this one. Now, to make a bridge on this one, like one tile I need here, I can skip this, then I will take 2 and then 1, right? Similarly, I can take this here, I can make 1 here and skip this and make 1 here. So 1 plus 2 plus 1, and so I think the answer for this should be equals to 4. Yeah, so we do have 4 here. The first in the first test case, the most profitable is the second row. Okay, it is not the top view but side view. The gray walls on the bridges. Wait a second. Side view. The gray cells, the bridge itself, white cells are empty cells. Black cells supports. So okay. Okay, now I get get the problem. So we have a support here, then we do needed a support here, and this is the maximum distance that could be. Yeah, yeah, yeah. Okay, okay. Hmm. I get it now. So clearly we need some values now. So obviously my answer will be at least 2. And now I need to find out the number of. But can I do this greedily? I don't want to use dynamic programming to because it will unnecessarily increase the time. I can't go till big of m square. That is the problem here. I mean, till n it is okay. I can, but for calculating it for every m, how can I do this in big of m into k? Wait a second. Can I do this in 100 into m into 100? So if I have something like 2 into 10 to the power 5 and I multiply it with 10 to the power 4, I can easily do this in 2 into 10 to the power 9. And what are the time constraints? It is 2 seconds, so I think it should pass. Yeah. Okay, let's try to do this. Let's say vector int answer of n vectors. Okay, for I range this. Now I want to calculate the values. So let's say vector int dp of n plus 1 and 0. Like, what will be the cost of building a bridge here? Now I know that a bridge must be built on the first row, like the first box and the last box, right? Um, so what should be my DP array? Like, if you are given a row like this, if you have a big row like this, so let's say A1, A2 till AN, and like, okay, um, I know that I have to take this and this. So for this, like, do I need to build a bridge here? So what should my DP of I represent? Minimum total cost of building the bridge, right? Building the support here. Okay. So if I'm at I mean, I have to build that at this index, right? Hmm. Okay. So what I can do is, like, if I'm at some index I, then I can check for all the I minus k cost and take the one with the minimum cost, and then I can skip all these values and then add to it like that. Yeah. Okay, but how can I do this efficiently? Because this is something like the convex hull trick, maybe. But I don't think in a Div 3 context they will give such a high thing like that. Okay, so what I will do is initially I will have, let's say, int max, because I mean, let's just say that, or let's say a very big value like this, to the power 60. Now dp of 0 is equals to, um, I mean, it will obviously be something like two units. I mean, it will take me 1 unit to make a shore at that, right? Then now I will go from j, from 1 to n, not m, till m. Okay. Now I have to traverse in reverse order. Like, okay, so I will go in the reverse order, or should I? Well, okay, let's just go in reverse order. Uh, for I range k. So I will start this loop from j minus 1. I mean, I am at j. Okay. I mean, why am I at j? I have to cover it for every index for I range. Now I have to go back some units. So let me change it to L, because I don't want to reuse the variables. Right. Okay. Now I'm going back some distances. And okay, when do I have to break this? The distances, there was something given like no more than d, that is these two minus 1. So if I have j minus k, what was it? Absolute value of j minus k plus 1. Sorry, j minus k minus 1 should be less than if it is greater than d, then I'll simply break out of this loop. Okay. And also, yeah, I think this is good. Now and dp of I is equals to minimum of dp of I, not dp of I, sorry, I should say dp of j is equals to minimum of dp of k plus, so what, dp of minimum dp of j comma dp of k plus the amount that it will take me to repair, to make a support on this current one. So I will say, what will be the amount? It will be equals to river of I and j, right? Plus 1. Yeah. And in the end, my answer will be stored in the end value. So I will say like, okay, answer of I is equals to dp of m minus 1, right? I think I forgot to take the input. So let's say for I in range 0 to n, and let's say for j in range this c in river ij. Okay. Uh, let's also debug the answer variable. This is not the correct input. Hmm. I mean, the answer should be n, right? So and that is why we are going like that. dp should go to until m, and now I think it is correct. Yeah. So the answer looks like 644 on this. And what is the L value? If L is 1, then I should simply select the minimum of this, which is 4. So yeah. Now I need to take the minimum consecutive sum, right? So to have the minimum consecutive sum of L, I can just simply use a sliding window. So int answer is equals to, let's say, int max, long int max, or let's say a very big number. Okay, and now int sum is equals to 0. I will go for I in range L, s plus equals to answer of I. For I in range from L to n, okay, I will say s minus equals to answer of um, like s plus equals to answer of I, and I minus L, and f answer, minimum f answer, comma s. Yeah. So this is my final answer. So we have 4, 8, 15, 14. This is correct. Let's try to submit this and see if it works. So I will also do this on m2.codeforces. So this is the E problem, and the language is C++17, and submit. Okay, it's testing. I think it will give me a TLE, but let's see. Yeah, it gave me a TLE. We still have an hour, and I think I can still optimize it. Yeah. Yeah, this is a doable problem. Yeah. So how do we go about this? Okay, now if I want to do this, okay, there are some changes in this problem. Okay, there are minor changes. Now, how do we optimize this? So to do that, I think this is a simple 1D optimization. Okay. I want to avoid like this is I want to avoid this part. Like, how do I avoid this part? Can I use a DQ? DQ of pair intent. I mean, I can use a DQ. And what will the DQ represent? I mean, I can use a set also. Um, like, okay, let's try to optimize this using a DQ. So let's say DQ. You can read about the 1D optimizations later. Now, if I want to use a DQ, let's say we have something like 1 comma at first index. Let's say something like this. If I have a DQ, so we have DQ of pair intent. Let's say Q. Okay. Now, I will say like Q dot push. And now I have to push what? I have to push a pair of index 0 because this is at 0 index and 1, right? Do I have to push front or push back? Let's just push back. It doesn't really matter. This is the first index. Now, if I have this, like, okay, so I said like, okay, in the on the 0th index, I will have a cost of 1. In the next operation, like if it is greater, I will push back. And yeah, I think if it is greater than this, then only I will push back. If it is less than this, then I will push front. I think like that. So I think I get it now. Okay. So what I will do is instead of I want to skip this part, right? So what can I do? If I want to skip this, then I will say like, okay, simply take the dp of j is equals to minimum of dp of j comma. I mean, I don't even have to take the minimum. I will say like dp, not dp. I think I will simply append the index instead. So this will become simply dq of integer. So I will push back the index 0 in this. And now dp of uh, q dot front plus a of not a in this part. So it will take me this much amount in for building this dp for building a support in this. Now before doing this, I have to say like while uh, q dot front minus j and the absolute value of this minus 1 uh, greater than d. So while I am too far, I will say q dot pop front, right? So I'm removing those indices that I don't need. Now, um, like okay, this is good. Like okay, now should I add this dp into the? The problem is if dp of j Like when should I add this? Let's try for some test case. So if we have something like uh, let's say 0 2 1 0 only. You have 0 2 1 0. Okay. Now initially, so the DP will look something like, okay, it will take 1 unit of here. Now if I want to build this, so it will take me it will take me 1 plus 3, so it will become 4. Now for 1, so in my queue it should look something like this. So in the front we have 1. Now I can still extend it. Sorry, my queue will look something like 0 and 1. And now I can still extend this. So I will say like, okay, let's say the answer will be like 1 plus 2, which is 3. And here it will be equal to, but now I can't have this. So where should I add this? Should I add it here or should I add it here? Now before adding this 3, I should remove all the indices which are great. Okay, I think I get it now. Okay, now while uh, q dot back is greater than dp of j, q dot pop back, and after this I will say like, okay, q dot push back what? I want to push back j. So I think this should work. So I also have to check that if my queue is not empty. So while not queue dot empty, and let's try to run this again. So we are getting some huge errors. Why is that? Okay, let's try to debug it for this test case. So answer is like 800. Okay, so for the first case, I think let's just remove this test case from here. What 0330? It's saying like, okay, um, the answer is like 1556. So it is taking me 1 plus, will it take 6? So if we have 0330, it will take me 1. Then I can have, what is the d value? D value is simply 2. So I can have, like if I have this, then I can extend this. The d value is 2, right? So I can say like 4, like 3 plus 5, 5, and then, okay, so it will take 6. So this is correct. Now let's also go till 2. Okay, in the second line only it is failing. Hmm. No, it is not like it isn't failing. Ah, so we have in the second line we have 0 2 1 0. So if we have 0 2 1 0, 0 2 1 0, the DP will look like 1. Then if I extend it, then we have 3 plus 1 4, or if I do it from here, then we have 2 plus 1 3, then 4. So this is incorrect that I have here. Now why is that? While absolute value of q dot front minus j is greater than d, then I need to pop it. Otherwise, I will say like dq of this. 1, 4, 3. Then why do we have a 5 here? Okay, I think I should say dp of q dot back is greater than equals to dp of j. Then I will need to pop it. Yeah, now we are getting correct answer. Let's go from 0 to m and not m till n and run this. Okay, so we are getting some very large values. Now, why is this happening? Hmm. So first we have 1556, then we get this value. So 1556 is correct. Let's say dp dot assign m comma 0, and let's also debug the dp array. And we are getting 7, which is close but not correct. Okay, so if we have this, then the answer should be, I mean, the answer should be like 4 plus 4, which is 8. What is the answer that we have? So we have 3, 4, which is incorrect. So oh, I think I get it now. This is because I am not clearing the queue here. This queue is outside this. That is why we are getting the wrong answers. So now it is giving correct answer. Yeah. Okay, let's try to do this once more and run this. So we are getting 4, 8, 4, 15, 14, which is correct. Let's remove the debug lines. Actually, I don't need to remove the debug lines, but it takes some time to print these, so I want to avoid that. You know. So this is the E problem and C++ 17 submit. Okay, we went till test case 9 and 11, 12, 13. I'm not sure. This still might give me a TLE or it might pass. I'm not sure. Yeah, okay, yeah. Actually, I solved it. That is nice. Ah, let's see what my current rank is. Okay, so my current rank is 1000, which is good. Now let's see the F problem also. Is the stream still working? Yeah, the stream is still working. So we have Rudolf and imbalances. Rudolf has prepared a set of n problems with complexities a1, a2, a3 till an. He is not entirely satisfied with the balance, and so he wants to add at most one problem to fix it. Okay. Wait a second. Let me just check the ranks again. I just want to check the my friend's rank or how the juniors are performing and all. So okay. Oh, I'm getting a plus 119, which is nice. Now we have okay, it's nice. Let's see. Okay, Rudolph has prepared a set of n problems with complexities these. He is not entirely satisfied with the balance, so he wants to add at most one problem to fix it. Okay. Now for this, Rudolph came up with m models of problems with and k functions. The complexities of the ith model is di, and the complexities of the jth function is fi. To create a problem, he selects the values I and j, and by combining the ith model with the jth function, what is this? The complexities of the ith model is di, and the complexity of the jth function is fi. Now, what is this model and function? Uh, so Rudolph came up with m models of the problems and k functions. Okay. The complexity of ith model is di, and the complexity of jth function is fi. To create a problem, he selects the values I and j, and by combining the ith model and jth function, he obtains a new problem complexity di and plus fi. Determine the imbalance of the set. Rudolph sorts the complexities of the problem in ascending order and finds the largest value of ai minus 1. What is the minimum value of the imbalance that Rudolph can achieve by adding at most one problem created according to the described rules? What is the minimum value of imbalance that Rudolph can achieve by adding at most one problem created according to the described rules? Hmm. He obtains a new problem of complexity. Let's. I can't actually understand this uh, line. What is the minimum value of the imbalance that Rudolph can achieve by adding at most one problem? Okay. Okay, I think I get it now. You want to minimize the value of imbalance? Hmm. This is nice. Let's actually take the input. So I have int n, m, and k. And after this, I have some values like integer array of n. So vector int a of n for I, c in a of I, and then we have m integers. Let's say vector int d of m for I, C in D of I. Then we have k integers of functions. So vector int f of k. This should go till m, not n. And then for I in range k, I will say k c in f of I. Okay. Now once this is done, okay, the fourth line, the complexity is it is guaranteed as now I want to add one problem to this such that the balance is not disturbed. Like the largest balance currently that we have is decreased. Okay. Um, so what do I really need? Like here the imbalance is zero already, so I don't even need to add anything. There is no explanation given to this problem. Why is that? Let's go to the F problem. So yeah, there is no explanation for this. Why is that? I don't like this. Okay, whatever. Let's try it. So we have 5, 10, 10. Let me just clear the pages. Okay. So at most one means that I don't even have to add something if I don't like it, right? And the imbalance is AI minus AI minus 1. Okay. Can this be negative? Like, is this always increasing? I mean, if this is decreasing, then why I don't even need to decrease it further, right? Huh. Okay, let's see. Like if I have 5, 5, 5, then the imbalance is 0. Here also the imbalance is 0. And can I add this new problem at the start or at the end? I mean, can I minimize this further? What do we have to print? The minimum imbalance that Rudolf can achieve. Okay, so it says the minimum imbalance that I can achieve is 5. Why is that? And initially it is. Oh, sorry, sir. Sorry. I did not read it properly. Okay. So here the imbalance is 5. Here also the imbalance is 5. Here also the imbalance is 5. And now we have a 6. So the maximum imbalance that we have is 6, right? I think whenever we have something like minimize the maximum and something like that, because we want to take the uh, wait a second, determine the imbalance set. Rudolph sorts the complexities of the problems in ascending order and finds the largest. Okay. So first we have to sort all the problems and then we want to do this. So whenever we have something like we want to minimize the maximum, it is generally a problem of binary search. Uh, so can I think in terms of binary search? Yeah, I think this is a problem of binary search. Okay. And because everything is like log n, log n, log n, so I think it is a problem of binary search. Yeah. Uh, but still, I should not force something, an algorithm in a problem. But the time limit is also 3 seconds. Everything in my mind is saying that, okay, try a binary search on this problem. I'm not sure. Let's try, let's just sort these values. So a dot begin, comma a dot end. So now I have sorted all these values. And I want to find the minimum imbalance that I can get. So for that, I will let's just use the binary search template. So this is like my binary search template. Now, okay, firstly I need to find the imbalance that I currently have, right? So I can go from 1 and current equals to 0. Let's say current is equals to max current comma a of I minus a of I minus 1, right? So currently we have something like this. I mean, this can't be less than 0 because they are in sorted order. So a of I minus a of I minus 1. So currently we have this, and now this should go till current, and answer is obviously initially the largest value. And I want to check that if I can I make this equals to, like, okay, this. So I think I should sort all of these, like, why not? I want to take one of the D value and one of the D's and one of the F's, right? So why am I storing it in a vector? Shouldn't I just add all of these in a set and just do a lower bound or upper bound, or simply a find operation like that? So I think that will be more fruitful. So let's say int x in x, and after that I will say d dot insert x, and similarly I can do it for this one. So let's make it a set of f and int x in x and f dot insert x. Okay, so now I have a set. So because I want to take at most one only, right? So why do I need to store the duplicates? I don't, right? So now we have this. Now to create the problem, he selects the values I and j, and by combining the ith model and jth function, he, okay. So how do we get a minimum imbalance like that? So clearly, if we want to find the minimum imbalance, I need to get the index of, like, okay, let's see. Let's try this problem only. So we have like 5, 5, 5. We have 5, 5, 5, and 6, right? So we have some number. What were the numbers that we have? We have like this. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And the largest of them was 26, right? So we have 5, 10, 15, 20, 26. 5, 10, 15, 20, and 26. Now, if I want to, can I have a minimum imbalance less than this? Now, if there are multiple occurrences, I can't, right? So what I should try is I should try to reduce this number as much as I can. Okay. So if I have the current as 6, can I reduce it to something like 3? My question should be, can I reduce it to 3? Okay. How will I reduce it to 3? I think my DNF are small. Are they? N, M, K are still too large. Yeah, they are still too large. This is something like a two pointer. I think I made a mistake by converting them to a set. I should use a two pointer and try to solve this problem. How much time do I have? I have 30 minutes, and okay, let's just convert it to vector int only. D of M. Okay, and now I want to say, like, okay, D dot sort F dot sort. Okay, so everything is sorted now. Now what can I do? So we have this. Now I will just select the largest number first of all. Now I want to, like, if I want to make the minimum as, like, if I have 20 and 26. So first of all, I will remove this. Then can I add a new number? My question should be like, can you add a new number? If I add 21, so this becomes 21, but that still remains. I mean, at max, I can make it like 3, right? Because if I add 23, then this becomes 3, this becomes 3, so 3 and 3 are added. So yeah, I can make it 3, but still the maximum will still be 5, like that. I mean, I can convert it to something lower, but I can't make it lower than the second maximum, right? Yeah. So I have to maintain two things, the maximum and the second maximum. Okay. So why don't I create a multi-set of these? Instead of doing it like this, I can say like, okay, let's say multi-set of integers m. Have I used m before? Yeah. Let's say ms. So ms dot insert what? What do I need to insert? Why is this giving some errors? Multiset is not declared in this scope. multiset. Okay, so multiset ms dot insert a of I minus a of I minus 1. Okay, so we have this multiset. Let me check my rank again. So 1200. Still pretty bad. Okay. Okay. F is doable. Yeah. F is really doable. Okay. Okay, so if you have a multiset, then what I can do is let's first insert everything. And now my question should be, can I reduce the number to something less? Like anything less than that should work. I mean, I don't really necessarily need to do it, but okay. Hmm. How can I do it? I mean, like I can say, I mean, why don't I create something like, do I need a multiset for this? Let's say a vector of an array. So let's say something like an array of int of size 3. So I will store three things. This is the imbalance array, and for I in range 1 to n, imbalance dot pushback, three things. First is a of I minus a of I minus 1, then I and I minus 1. So I will exactly know where I'm going wrong. So then I will sort, I should sort it in reverse order, right? So I will say like imbalance dot r begin and imbalance dot r end, right? Yeah. Now we have this. What can we do? Once I sorted in reverse order, I have these values and I will have the greatest value at the start. Now my question should be, can I reduce it or I can't I reduce it? It is a very simple problem. I think I can make this one of these into a set. I don't need to make both of them into a set. And let's say f dot insert x. Which is smaller, M or K? M or K? Both are till AI is still this point, that is okay. Okay, it is given, I don't even need to sort these values. It is already given that it will be sorted. Now, my question should be like, okay, if I want to do this, I mean, I can do this only once. And now, if it is an odd number, like what will be the difference between AI and AI minus 1? Like if I have the difference as something like this, I know my AI and I know my AI plus 1 or AI minus 1. So this is my AI minus 1 and this is AI. We have some differences, okay? And I want to decrease it as much as I can. I want to decrease it at least to the second value. So what is the second value? And the new value which will equals to imbalance of 1 dot like that. So we have something like this. Um, can I debug NV? Why are we getting errors? I don't need to sort these. Yeah. Okay, let me just copy this whole thing again. Okay. And the correct output is this. Yeah. Ah. Okay, so NV is 5. Okay. And I need to think like, can I reduce it further? How can I reduce it further? Now, if I want to reduce it to at least that, so if the distance between these is D, I can, at most I can reduce it by D by 2, right? So that is the max that I can get. So clearly, this is only possible if nu V is greater than or equals to D by 2, right? Like what if I have odd numbers, like if I have 1 and 3, let's say 1 and 4, because then the difference is odd. Even if I add a 2 here, if I add a 2, that this becomes like 2, sorry, 1, and this is equals to 2. So yeah, then we have a difference of 2. But if I put 3 here, then becomes this, and yeah, then we have 3 by 2 plus 1. So I think I can say simply say n plus 1 by 2. Yeah. So if nu v, that the next thing is going to become is greater than or equals to d plus 1 upon 2. Okay, then what can we do? Hmm. I mean, I have not actually accounted for. No, 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 no. I mean, it is always optimal to add a problem, right? If I want to decrease it, like okay, I want to add a problem, like let's say it will be decreased by something at least, right? So initially, like int nv is equals to imbalance of 0 0. So initially I have something like this, then Let's traverse in this for I in range M. Now, what is the problem with this? Okay, let's traverse in this for I in range M. And now if I have this, then for every index of D, I want to check if I can add something to it and make it possible. Hmm. Okay. What can I add into this array that I want to check? Let me check my submissions. This is like really fast, 62 milliseconds. How many people actually solved this? 2000 people. Hmm. I mean, this is a doable problem. This is a really doable problem now. Okay. Now I want to check if I can do something. Like if I have the distance, then I can break it into 1 and d minus 1, or I can break it into 2 and d minus 2, and something like this. So in the end, I can do it like this. So I just need to check if I can make it equals to at least the second maximum, right? Yeah. So one of these values, like if I have AI and AI, say A1 and A2, like this, then I want to insert something like this difference is 1 and this difference is d minus 1, or something like this. At least that. So let's say the second imbalance is, yeah, I think I should consider the second imbalance. So it will be equals to this, and A1 is equals to imbalance of and A2 is equals to imbalance of 0 of 2. Okay, so you have this, and the current value imbalance of 0 of 0. Okay, and this is what I want to make. Hmm. Okay, so if I have A1, A2, and I want to make some D dash, I should place A1 plus D dash, or A1 A2 minus D dash here at least. So I can either place A1 plus D dash here, or A2 plus A2 minus D dash, because if it, so in this range I can place the numbers. So I want to find at least one number in this range, and I will be good to go. So obviously if A1 plus D dash is greater than A2 minus D dash, yeah, so we have this. Okay, so how do I find such if such a number exists uh, in this range or not? First of all, like if I set a number, then I will do a lower bound for it and then check if it exists. Like if I can have such a number, which is at least at this distance. Okay. So in the new A should be equals to, let's say, A1 plus new value. So the new value that I want. Okay. and I want to search that I add this value in this number or not. So I want to search if I can make this using these two arrays, the D and F. Okay, so I will say like, okay, for I range this, and now how can I actually search for this? Let's say there is only one test case and debug A, debug D, and debug F. So what am I getting? Okay, so if I want to have at least 5 here, so I can I make 25? That is the question. Now if I have 8, so from 8 maximum I can go to 16, so I can make 24, but now I can't make it. So I will try to increase it. So first of so I will try to increase it again, and okay. So for every I, if my current is equals to A of I, not A of I, it should be D of I, and the thing that I want to search is equals to new A minus current. Okay, so this is what I want to search. If I find it, if f dot find search not equals to f dot end. Okay, so if I actually find it, then I will say okay, see out new value and return, right? And then I will say like same thing, new A is equals to what if I can't make it exactly that, but I can make it something less than that. That is something that I have to account for. So since I want to make it greater than this number, I mean like okay, so vector int, um, we have a1 plus new value, comma a2 minus new value. So we have this now sort a, new a dot begin, comma new a dot end. Okay, so I want to have something like just greater than this value. Okay, now do I need this new a? No, I don't think I don't need this new a. Okay. No, now I don't want to find this. I want to find the for at least something that is this number. And if I find it not equals to f dot end, then I will simply print it. Yeah, that is correct. Otherwise, let's say my new a is equals to new a of 1, and now I want to search for this again, but this will be a bit different. Why? Because now I want this number to be not equal to f dot begin. I mean, okay. Otherwise, I will see out imbalance of 0 0. Okay, this is correct. Let's make it 2 and see. We're getting 3, which is wrong. So 1, 2, 3. So let's remove these. Okay. So our A value looks something like this. Then we have something like imbalance array. There is only 12 minutes remaining. I think I will stop here. I mean, I could, but I need to edit this video. I could keep trying for 10 minutes more, but I think I need to edit this video a bit before actually making it public. So thanks guys if you watched it till here, and if you learned something, kindly like this video and subscribe to the channel. And if you have any doubts, you can post them in the comments. I will see you guys next time. Thank you. Okay.